Hey everyone, Mr. Skelton here. We are back at it. We're starting Unit 9. We're going to do Lesson 1 today. And we're going to be talking about probability in this first lesson in Unit 9. And there's two kinds that we're going to be discussing. We're going to be talking about theoretical and experimental probability. Probability is something, my guess is, you've heard before. I believe we do some in geometry. We do some geometric probability in your geometry class. I don't know, I can't recall if you did anything in Algebra 1, but I don't think this would be your first time doing some basic probability, okay? So I got the first couple slides just really kind of brief you and maybe reintroduce the concept to you. A learning target is pretty basic. I can describe the difference between theoretical and experimental probability, and then we're going to apply those concepts to some problems. So, second slide here, what is probability? Basic probability measures how likely an event is to occur. You can express probability as a percentage, so anywhere from 0% to 100%, or as real numbers, such most commonly as fractions between 0 and 1. So if you think about the connection here, 0 to 100%, 0 to 1, this would be like the decimal version, and then moving the decimal 2 spots over would be the percentage. So you can express it either way, okay? An impossible event is 0%. The probability of a certain event, which must happen, is 1 or 100. Right? The sun coming up every day, pretty certain that's going to happen. 100% probability. Another couple other words here. Sample space. A sample space is is an example of a sample space is when you roll a number cube or a die. The possible outcomes are 1 through 6. The set of all possible outcomes is called the sample space. So it's basically all the possible options that are out there. That would, if you see that word or you hear me refer to a sample space, that's what we're talking about. All the possibilities that are there. Okay. You can calculate theoretical probability as a this should be, I don't know why I put ration. It should be ratio, as a ratio or a fraction of the outcomes. Okay. So just some vocab there, just kind of bring you back to speed with some probability if you forgot from your geometry. So let's take a look at a certain situation here. And we're going to focus on theoretical probability first. Nice in color today, I like it. So theoretical probability is solely based on the sample space shown without doing any action or experiments. So it's like in theory. In theory, this should happen X amount of times. It's kind of like the thought. So theoretical probability is all based on theory. What could happen, what could happen, but we're not actually doing any experiments to figure out what actually happened. So it's all in theory. So let's take a look at this example here. According to theoretical probability, how many times can we expect to land on each color if we take 16 spins? Well, each of these, like green, yellow, and red, these are the bigger chunks, and you can see that these are basically quarters, right? So if we did 4 quarters, green would be a fourth, right? And if we spun one time, it'd be landing on that would be 1/4, because there's 4 total, 1 option. Yellow would be a fourth. Red would be a fourth. Now white and purple, those have been cut up. That fourth has been cut up. So basically, if you were to cut up the rest of these, just like you did with the purple and red, how many spots or total possibilities would you have? You'd have 1, 2, 3, 4, 5, 6, 7, 8. So white would be 1/8. Purple would also be 1/8. Okay? If you spun the spinner one time, that would be your probability. But now look, we want to land, or it says according to theoretical probability, how many times can we expect to land on each color if we take 16 spins? Okay? So what we want to do then is focus on the denominators. We want to make all of these be 16, right? And so we would basically times that by 4, times that by 4, times that by 4, times that by 4, by 4, by 4, by 2, by 2, by 2, by 2. Whatever you do to the top, you have to do to the bottom. So 4, 16, 4, 16, 4, 16, 2 16s, 2 16s. So theoretically speaking, if we spun the spinner, it's kind of hard to see the spinner, it's this white piece right here, I'll kind of put an arrow there at the end. If we spun that 16 times, in theory, we should land on green 4 times. We should land on yellow 4 times. We should land on red 4 times, twice on white, twice on purple, in theory. That's theoretical probability, okay? So, changing gears now, experimental probability is when you gather data from experiments. A lot of times they're referred to as observations, and you can calculate the actual probability something took place. So come back up here, and let's say, you know, we ran the experiment. Here's green, here's yellow, here's red, here's white, here's purple, and let's say, you know, we got 5 there, 2 there, 3 there, 3 there, and 5 there. So we ran an experiment and did it 16 times, and we kept track of, and I know that's not 16, I'm just making an example, but let's just say, you know, 5 out of 16 times it was on green, and 2 out of 16 was yellow, and then I did 3 and I put a cross through it there. 3, so 3 out of 16. I put a tick mark through all of those. Let's do 2 there. All right, so 2 out of 16 for white, and then 5 out of 16. So if we actually did the spinner 16 times, this would be an example of experimental, is what actually took place versus theoretical. Okay, so just a few quick examples here at the bottom, pretty basic. A baseball player got a hit 21 times when he was up to bat out of 60 at-bats. Find the probability of him getting a hit. When you create fractions with probability, here's the basic outline of, here's basically what I teach in geometry. What you want to happen, I'm going to make this, there's my division bar, total outcomes. Okay? That's your fraction for probability, essentially. So what do we want, what do we want to have happen, or what did happen? We got 21 hits. What was the total amount of outcomes? 60 at-bats. All right? So that's the experimental probability. Now, more times than not, we usually, because we like percentages better, we would just divide those out, get your calculator out, you get 0.35. So that equals 0.35 or 35%. Right? Most of us cognitively can think percentages, so if you said, hey, that person got a hit 35% of the time, we can kind of, we can see that in our head, right? We can kind of figure that out, as opposed to, hey, 21 out of 60 is the probability. We like the percentages. It's a little bit more easy on our brain. Okay? Basketball player made 56 out of 80 free throws. What's the probability of making free throws? Same situation. What did we want to have happen? 56 out of the 80. So again, you take 56 divided by 80, and you get 0.7. So that person shot 70%, right? Move the decimal place over 2 spots to make it a percentage. So you got 70% free throw shooter there. Not very good. Okay? Moving on. So the second part of our learning target, and I didn't put this on here, is we're talking about the difference between frequency and relative frequency. So it's 2 different things. So I'll put 1 and 2 to make sure you understand it's 2 different concepts, but they're very similar. So we're talking here about categorical data. Categorical data is based on, like, you know, gender, so boys and girls, you know, eye color, you could do grade, you know, something that's going to fit into categories, right? That's called categorical data. So these are categorical data. Frequency. Frequency, when we talk just straight up frequency, it's with experimental probability, and we just, it's like this situation right here. This is called a distribution table or a frequency table, by the way, both of these. It's like saying, okay, 15 people, it's just like a random population. 15 of those people had blue eye color, 20 had brown, and green or other was, you know, 30, okay? And let's say we're, this would be 30, that's 50, that's 65. So 65 total. I'm just making something up here. There's 65 total. This right here is an example of just finding the frequency. That would be finding the frequency, is just doing the experiment, figuring out the frequency right there. Relative frequency is creating a percentage from the total, okay? So what I mean by that is, okay, blue had 15, there's 65 total, so to figure out that percentage, it's 15 out of 65. Take your calculator out, 15 divided by 65, hit equals, and we basically get 23%. So 23%. That's relative frequency. Really basic stuff, but just knowing the difference between the two is something you will need to know. Brown, same thing. 20 was the total. So for Brown, we go 20 out of 65. So 20 divided by 65, it equals, we get basically 30.7%. Okay? And then green, another was 30. So 30 out of 60, you don't even need to do that one. That's 50%. Okay? So relative frequency is just taking an extra step and actually finding the experimental probability with percentages. Frequency is just basically tallying up the number of subjects or outcomes that you had. All right? That's it for the first lesson. Pretty basic stuff, just kind of easing you into probability, but some good vocabulary here, just some things you need to be aware of as we move forward through this new unit. As always, if you have questions, look forward to seeing you in class. Take care.